Welcome to the ePathshala lecture series, UGC lecture series in computer science. In this series of subjects, I am handling software engineering, and for today's session, I will be working or continuing with software development lifecycle. In the previous session, I have described about waterfall model, and today we will be looking at code and fix model. This also follows a sequence where I go through the user requirements, I understand the business requirements, software requirements, I draw the architecture, I go for the detailed design, I go for testing, implementation and testing, finally it will be deployed. But before deployment, I try to understand this as the first version, because my requirements quite often vary, which was the major disadvantage of the waterfall model. So for that reason, I consider whatever stages that I have gone across as the first version of it. So implement the first version of the software. If there are any rectifications to it, modify until the clients are satisfied. So after my first version of it, I try to modify every now and then wherever my client specifies me with the change of requirements or asks me to change the way in which it looks like, modify the clients up to its satisfaction. So this happens as an iterative phase. Again and again it reiterates until the clients satisfy this particular activity. Once this modification has been carried out and my client is found to be satisfactory, I will be giving it for post delivery and maintenance. So after it has been deployed to the end user, it should be maintained. So then I come to a retirement phase. So anything that has been marked on a full length line, that is called a development phase, whereas anything which has been mentioned in the diagram with a dotted line, it is called a maintenance phase. As you can very well see, there are no designs involved in it. Basically I start developing with whatever methodology I wanted to build in. Basically if you can ask me a question on what sort of projects would work better on a code and fix model, anything which is very simple in terms of understanding. Once the client specifies the complete requirements of the product at a simplest level, and I find this particular project as very simple activity to be done, I can directly start coding and fix up whatever errors that turns up. So there has been basically no specifications and design for this particular model. So this being the easiest way to develop a software. Instead, this should have been the first model. Build and fix or code and fix would be the first model before we arrive at a sequence of phases to be carried out. And in a way, although it seems to be pretty easy, as students you might be developing a code and fix model, because during laboratory sessions you will be directly involved towards coding once having set a problem on Fibonacci series, or to write a program to find 1, -2, 3, -4, this series of sequence. Although I say a problem statement, you can directly code on it. It does not require a complete set of requirements. Likewise, this seems to be the easiest way to develop a software. Although it is easy to develop, but it requires quite a lot of maintenance, and the maintenance is not as estimated, it is much costlier than what we have expected. So the most expensive way for maintenance, and maintenance seems to be a nightmare many a times. Looking further at this code and fix model, the product is implemented without requirements or specifications or any attempted design, which exactly means I have never posted on the requirements. I basically try to understand. There is no documentation related to the requirements. There has been no documentation mentioned towards specification, and there has been no design specifications also. So the developers simply throw code together and rework it as many times as necessary to satisfy the client. So this is the fundamental idea behind the code and fix model, where the developers simply understand what is to be developed and they try to satisfy the clients as much as possible. So it is used in a smaller project, and it is totally unsatisfactory for products of any reasonable size. So as it has clearly mentioned, this kind of development would work much better for simpler projects or for a small projects. anything which has to be coded between say 50 lines of code to 100 lines of code or a maximum of 200 lines of code would effectively work on this kind of a model. But then when I look at certain complex activities where design is utmost required, this model may not be preferable. So this particular model is totally unsatisfactory for projects or products that are to be developed basically with software for any unreasonable size. Further, to look about this code and fix model, this model starts with an informal general product idea and just develops code until the product is ready. So it basically tries to concentrate again and again on the coding aspect of it until I say the product is ready to be delivered to the client, or money or time runs out. Work is in random order. I can work on this particular system on anything that I find is very much feasible. So this corresponds with no plan. Some of the advantages of this particular code and fix model would involve there is no administrative overhead found towards this code and fix model. Signs of progress in terms of code early in the life cycle development model. So we have skipped on the requirements, we have skipped on the analysis phase, we have skipped on the design phase, we have directly landed on a coding phase. So any person who is of low expertise, anyone can use this particular model. So this is just a beginning for a small proof of concept projects, and for example as a part of risk reduction. So a project which basically can be a proof of concept at the beginning, which does not involve a major quantum of risk, can be shown as of this type, this model type. Some of the disadvantages. Majorly this has not been advantageous, as I have earlier mentioned. There seems to be no design, there seems to be no specification, no documentation available, so it is highly dangerous in nature. And further, if you could refer to the previous session, I was talking about planning, I was talking about visibility of the project. So this does not even cover on the planning aspect and the visibility aspect. So there is no visibility and control over the project, and we do not have to estimate on the resources also. There are no hard and fast rules towards deadlines, and some of the mistakes which I have mentioned towards this particular model are hard to detect and correct. So many a times as I have started coding on this particular aspect, I may not understand the risk involved towards this product, and sometimes I may go on an error also. My entire intention is to satisfy my clients, that is it. So if I am too largely towards satisfying my client's expectation would quite often change, so which cannot be adopted. So by where lot of errors might turn up. So mistakes are hard to detect and correct and impossible. This particular model is impossible for largest projects, and it comes out with largest communication breakdown, and it is a major chaos for us. So for these specific reasons towards code and fix model and some of the disadvantages of the previous model called waterfall model, we wish to proceed with certain other models which is called a spiral model. This particular spiral model has advantage towards one specific event which you may have to remember, which is called a risk management activity. As far as waterfall model and code and fix model is concerned, we have not majorly concentrated on the risk factors at the beginning of the requirements collection itself, whereas the spiral model talks more of a risk and the outcome towards the project. So this is the primary objective towards working on a spiral model. End users are hard to obtain, define, it is natural to develop a software in an experimental way. For example, we can build some software, see if it meets customer requirements. If not, go to step number 1, else you stop. So this loop approach gives rise to structured iterative life cycle models. That means I am asked to develop a software. If it meets the entire requirements given by my customer, if it is all been met, I continue, otherwise I stop. So this has been an iterative process so long. That is what I have been mentioned. It has been a structured iterative life cycle model, and this particular model has been initially coined by Boehm. It's specifically called Boehm's spiral model. In 1988, he developed this model called spiral model as an iterative model which includes a risk analysis and risk management. So these two are mentioned to be the key ideas behind the spiral model. One is called risk analysis, the other one would be risk management. Now look at the entire model structure, where it has been divided into 4 phases. We will start with the first phase, which is called determine objectives, alternates and constraints. So given any specific project, the main objective of the project is to understand the objective behind why I have to approach on the particular problem. So first we try to understand the objectives of the project. Are there any alternate flows in case of any errors found, and are there any project constraints majorly that we were talking at the beginning of session 4. We were talking about staff, we were talking about money, we were talking about infrastructure, we were talking about time. So these 4 are the underlying facts about the constraints. When we are about to look at these constraints, there are so many issues that might come across when we work on the project. So I would start on the project at this level, which is not at the index. So I would initially understand on all the aspects of the objectives, which takes some of my time. So I work back, I understand the complete requirements of the project, then I start building up a prototype initially. So as a second phase, the first phase is to basically figure out what my objectives are, what my alternatives are, what my constraints are. The second phase is to majorly talk about evaluating the alternatives, identifying and resolving the risks. So whatever risk that has been pointed out during the alternative phase, where and all the risk majorly arises, those will be sorted and the prototype being built at phase 2. At phase 3, it's a typical process where we develop, verify and produce it to the next level product. And phase 4 will majorly concentrate on the planning towards next phase. So it revolves around only these 4 phases. I repeat whatever I have said. Phase 1 is more on talking about objectives, alternatives and constraints. Phase 2 about alternatives, identifying and resolving risks. Phase 3 is about developing and verifying next level product, and phase 4 about planning for the next phase. So when we are at the phase 1, we will be talking majorly on the objectives, and whatever objectives that we have defined in the beginning, we will be working on those objectives as a development, as a prototype. A simplest prototype will be built, and we will be going across the sequence of phases only at phase 3, where we exactly develop and verify on the next level of a product. And if you look at the entire structure, the proof of concept, requirements planning, design and validation, verification, detailed design, coding, testing aspects of it is only 25% of the overall development phase. That is at the phase 3. If I involve all 4 phases, only 25% of the time I will be talking about these development and verification. The rest of the times I will be either concentrating on the risk or at the development of prototype by looking at the various alternatives. So this particular picture is being plotted towards different modes of operation or different sequences of this particular model towards estimated with respect to the cost. So each cycle of this particular model is being estimated with determining objectives, specifying constraints, generating alternatives, identifying risk, resolving the risk, developing the next level product and planning for the next cycle. As it was very clear from the picture itself, my ultimate objective towards working on this particular model is to understand and analyze on the risk factors and manage it with alternates towards building up a prototype. So this becomes a major advantage towards this particular system. So mentioning the advantages of spiral model, in realism, The model accurately reflects the iterative nature of software development on projects with unclear requirements. Even though I am unclear of certain requirements in the beginning of the work, there might be a possibility of heavy risk that could happen, which will be indicated in the beginning of development phase itself. And it is flexible, which means it incorporates the advantages of waterfall and rapid prototyping methods. Comprehensive model decreases risk and it shows a very good project visibility. As a next initiative, we will be looking at a rapid prototyping model. By the word rapid, I would mean within a fast or in terms of time, I will be developing this particular project in a faster manner, in a speedy manner. So now that it is my responsibility, I have not understood the project, or I will be very clear of the project until it has come across to a deployment phase. So when I am at the requirement phase, although I am a customer, I have given my complete specification. Until it has been deployed to me, I am not getting a rough picture of how my project would be. So for that particular juncture, this rapid prototyping would be an alternate to a waterfall model. For customers who require a simple workout of how a system would be, say for example, many of us might have an intention of a website developing for a company or for a hotel. They would require, or they would have had in their mind a blueprint of how this website should look like. So it should be, they will come out with to us saying all their requirements, and this should be complete in all these aspects would be their requirement. But then as an add-on, they would suggest, this is a website that I have come across which contains all this information, why don't you develop similar kind of a website? So that is a key indicator here. So for developing a prototyping model, our initial intention would be, we develop a simple prototype with a certain list of requirements. We take up certain requirements and we make the customer understand and satisfy on what is to be developed. And this is how the development would be as it progresses. So by where my client will be satisfied. So the key idea behind rapid prototyping model would be, customers are non-technical people and they usually don't know what they want and what they can have. So this rapid prototyping emphasizes requirement analysis and validation, and it's also called customer oriented development. Although waterfall model, code and fix model were oriented towards customer, the major aspect that I will be talking on this particular rapid prototyping is to uncover all the requirements, to work on some simple requirements and make the customer understand what kind of development would happen and how it will look like. So this is also called an evolutionary prototyping model. So this model would appear something like this, and this is a rapid prototype workflow where I capture all the requirements from my customers or my clients. I understand the complete set of requirements, but then as a next stage, when you compare with the previous model, as a next stage we would have gone for analysis and specification, we would have gone for design. But then after we clearly understand on the requirements of this specific model called rapid prototyping model, we are understanding on a quick design, which means I am taking a specific module where I am plotting on the design and I build a prototype. So which will make the customer quite more satisfied that this is how the development would clearly indicate. So this will be given to the customers for evaluation purposes. So after looking at this particular type of a simple workout or a prototype, the customer can come to an intention of, okay, this will be my product that I was expecting, and the feedback can be reiterated. If at all it was not found to be satisfactory, it can be reiterated. So once certain stages that we have introduced in this particular rapid prototyping model is something like this. We look at the requirements capture. Before we give it as a final product, It undergoes a certain different stages like quick design, building up a simple prototype, evaluating with the customer, which has not happened with the previous models. It evaluates with the customers and the iteration project process goes on. Once the customer is found to be happy, then I will be delivering the final version of it. So to look at more detail about rapid prototyping model, a rapid prototype is a working model that is functionally equivalent to a subset of the product. So the first step is to build a rapid prototype and let the client and future users interact and experiment with the rapid prototype. So the major strengths of this particular rapid prototyping model include the development of a product is essentially linear, proceeding from the rapid prototype to the delivered product. The feedback loops of the waterfall model are less likely to be needed in the rapid prototyping model. It is built rapidly and modified rapidly to reflect the client's need. So which means the speed is the essence here. Rapid, I mentioned earlier, it was the speed of delivery. So it is within less time I am trying to produce the product with utmost quality. So some of the advantages of this rapid prototyping model would include it reduces risk of incorrect user requirements, good where the requirements are changing and uncommitted, regular visible progress aids management, supports early product marketing, and disadvantages are an unstable, badly implemented prototype often becomes a final product. So since it is found to be unstable many a times, some of the badly implemented prototype can also be delivered as a final product towards early marketing. So which seems to be a major drawback with this particular system. So when we continue with some of more disadvantages of this rapid prototyping model, it requires an extensive customer collaboration where it involves customers cost, customers money, needs committed customers, difficult to finish if customers withdraw, maybe too customer specific, no broad marketing is involved. The prime reason why we talk more about customers is as a third or fourth phase we were underlying on the responses from the customers. If the response from the customer is not that satisfactory or if the customer tries to withdraw, the cost incurred would be more, the risk of the project development would be more. So difficult to know how long the project will last. Easy to fall into code and fix without proper requirement analysis, design, customer evaluation and feedback. So if you remove requirement analysis, design, customer evaluation from this particular structure of rapid prototype, it is obviously something like code and fix model. So as an alternate, what else could be done? It's just not an alternate, it is just an extension. So what we tend to do is, and we will develop an open source lifecycle model where it is something like the code and fix model where we have implemented the first version, but then we concentrate more on the maintenance phase of it. So if we look at the maintenance phase, so since we are talking more of the maintenance, we call this model as a post delivery maintenance lifecycle model apart from open source lifecycle model. So although I have gone through the sequence of all these phases, but then this particular model during its phase of maintenance, it will perform corrective, perfective, adaptive maintenance stages and it will be going for retirement. So my open source will continuously be monitoring on these three maintenance activities like corrective, perfective and adaptive maintenance stages. So the first informal phase of this open source life cycle include one individual builds an initial version and makes it available via the internet. Say for example, we have been using SourceForge. If there is a sufficient interest in the project, the initial version is widely downloaded. So many people try to download this particular activity from the website and users become co-developers. As and when they develop, the users become co-developers where they highlight the comments attached to it and the product is extended. So the key point lying in the first informal phase is individuals generally work voluntarily on an open source project in their spare time. So they can make any modifications on top of what has been established. It's because the nature is purely open source. The second informal phase would be on, they'll be working on, as I've mentioned, they'll be working on the corrective, adaptive and perfective maintenance. So reporting and correcting defects can happen, adding additional features to what has been already been existing since the code is open. Porting the program to the new environment can also be easily done. So the second informal phase consists solely on the post-delivery maintenance, the word code developers. So anybody who has developed on this particular project is also been involved, but on top of it, during the maintenance phase, although it has been given for delivery, after that people who are working on top of what has been given, those people are called code developers on the previous slide, should rather be co-maintainers also, because they also develop and they also maintain on what has been delivered already. So an initial working version is produced using rapid prototyping model, the code and fix model and open source lifecycle model. So the initial version of the rapid prototyping model is then discarded. The initial versions of code and fix model and open source model become the target product. There are generally no specification, no design. However, open source software production has attracted some of the world's finest software experts. They can function effectively without specifications or design. And today's generation, most fortunately, they prefer to go in for an open source lifecycle model. A point will be reached when the open source product is no longer maintainable. So the open source lifecycle model is restricted in its applicability. It can be extremely successful for infrastructure projects such as building up a new operating system. Today, many people started working with open source operating system like Linux, Mac, Darwin, OpenBSD, and there are open source browsers that are available like Firefox, Netscape, compilers like GCC, web servers like Apache and database management system like MySQL. There cannot be an open source development of a software product to be used in just one commercial organization. So the open source software lifecycle is inapplicable unless the target product is viewed by a wide range of users as useful. So how can we compare ourselves with the models that we have studied with the open source model? A closed source software is maintained and tested purely by employees. Users can submit failure reports but never fault reports. Whereas if you look at open source software, it has generally been maintained by unpaid volunteers who are called co-maintainers, co-developers. So any number of co-developers can work on top of what is existing in the internet. Users are strongly encouraged to submit defect reports, both failure reports and fault reports. So if you look at the core group, small number of dedicated maintainers with the inclination of time and necessary skills to submit fault reports, particularly fixes. They take responsibility for managing the projects. They have an authority to install fixes, and this is specific to a core group. Whereas if you talk about the peripheral group, users who choose to submit defect reports from time to time. Talking more about the open source lifecycle model, new versions of closed source software are typically released roughly once a year. If you look at closed source lifecycle models, it will be released once a year after careful testing by a software quality assurance group. This was mentioned with waterfall, starting from waterfall lifecycle model. The core group releases a new version of open source product as soon as it is ready. Perhaps a month or even a day after a previous version was released. The core group performs minimal testing. Extensive testing is performed by the members of the peripheral group in the course of utilizing the software. So it releases early and quite often. As a summary to this particular session, I have talked more about software development lifecycle, starting from code and fix model, spiral model, rapid prototyping model, open source model, and further I have at last compared open source model with the closed source model like the models which we have seen earlier. Thank you.